Welcome to the e-learning program for basic water applications. This course module covers the technical fundamentals of products for the treatment of potable water. After completing this module, you will be able to describe water as the fundamental resource, explain how to monitor and ensure quality of water by different technologies, describe mag meters, analytical differential pressure, continuous water analyzers and level products with their working principles in the water cycle. Water is our most fundamental natural resource. What we drink today is the same water that the first fish swam in, and that froze across much of the globe during the ice ages. Our planet probably has no more or no less water than it has ever had. And yet in some places we're beginning to run out of water. Underground reserves that farmers could once reach by dropping a bucket into a well only a few feet deep are now so low that a hole bored half a mile down still finds no water. Water resources around the globe are threatened by climate change, misuse, and pollution. There are many challenges facing the water industry today. Increased population, aging infrastructure, and transition from legacy systems and outdated methods. Increasing demands on labor to maintain the system, to meet the demands of an increasing population. Also, the current workforce needs to be re-educated on enforcing government regulations to give us better health, safety, and environmental conditions. Besides challenges to the global water market segment, there are local regulations and compliance issues that are driving the market. Increased regulatory compliance, the cost of energy, the reduction in operational expenditures, the need to increase the process efficiencies, outdated plants, and new technology advancements. Here are the types of water sources. Upland lakes and reservoirs. Typically located in the headwaters of river systems, upland reservoirs are usually sited above any human habitation and may be surrounded by a protective zone to restrict the opportunities for contamination. Bacteria and pathogen levels are usually low, but where uplands are forested or peaty, humic acids can color the water. Many upland sources have low pH, which require adjustment. Rivers, canals, and lowland reservoirs. Lowland surface waters will have a significant bacterial load and may also contain algae, suspended solids, and a variety of dissolved constituents. Groundwater. The water emerging from some deep groundwater may have fallen as rain many tens, hundreds, thousands of years ago. Soil and rock layers naturally filter the groundwater to a high degree of clarity before the treatment plant. Deep groundwater is generally of very high quality. That's to say, pathogenic bacteria or the pathogenic protozoa are typically absent, but the water typically is rich in dissolved solids. There may be a requirement to reduce the iron or manganese content of this water to make it pleasant for drinking, cooking, and laundry use. The water cycle is an extremely complex cycle, and it can be contaminated by several different agents, including rainfall that erodes rock and decaying of vegetation. Much of it is contaminated by human activity, including mining, sewage discharge, industrial waste, farming, and illegal dumping. And even the soil condition itself can affect the amount of contamination in our water cycle. Regardless of the source of water, some monitoring and removal of contaminants to the water system is normally necessary. In this portion of the e-learning, we will look at 4 different applications and monitoring and methods of removal. The first being the raw water supply, coagulation control, final chemical treatment, and final water quality testing. If we take the example coagulation control, each plant in each region will vary based on the amount of contaminants entering the plant. Several points of measurement are located throughout the plant, which include measurements like turbidity, color, which allow proper control in the coagulation bed and settlement tanks. Also, measurements are taken after the process to ensure that the final product is clean. In this slide, we will see the entire process of water treatment and distribution. As noted earlier, water intake comes from many different sources, including boreholes, rivers, and groundwater. Also, desalinization and other collection methods are prevalent within the water market today. Once collected and brought into the plant, they are treated, first through screening. The first step in purifying surface water is to remove large debris such as sticks, leaves, trash, and other large particles which may interfere with subsequent purification steps. Most deep groundwater does not need screening before other purification steps. Storage. Water from rivers may also be stored in bankside reservoirs for periods between a few days and many months to allow natural biological purification to take place. This is especially important if treatment is by slow sand filters. Storage reservoirs also provide a buffer against short periods of drought, or to allow water supply to be maintained during transitory pollution incidents in the source river. Preconditioning. Water rich in hardness salts is treated with soda ash to precipitate calcium chloride out. Pre-chlorination. In many plants, the incoming water was chlorinated to minimize the growth of fouling organisms on the pipework and tanks. Because of the potential adverse quality effects, this has largely been discontinued. Then through coagulation, settlement, sand filters and disinfection, and finally to storage. After storage, the water is then sent out into the system over a distribution channel to the customers in the industrial, commercial, and residential sites. In this slide, we will see the entire process of water treatment and distribution. As noted earlier, water intake comes from many different sources, including boreholes, river, and groundwater. Also, desalinization and other coagulant methods are prevalent today. Once collected and brought into the plant, they're treated through coagulation and flocculation. Clarification and filtration stages before disinfection and any final water treatment such as fluoridation before finally going to water.